So, we are in week 7. 7. All right. And what are we going to talk about? Well, I don't know. Let's see what I talked about last time first. And tell you that. Just a quick review. And then we'll move from there to this week's order of business. Close this. Am I recording this? Yes, I am. Okay, so let's go to Sea Lion. And see what I told you last time and go from there. All right, so reviewing functions and the different kinds of variables and all that good stuff. So first of all, global variable. What is a global variable? Well, it's a variable that is declared before and outside all the other functions, which means that this variable can be seen, can be used, can be changed inside of any of the functions in there, right? So you can change it in the main, you can change it in any of the functions that you have defined. Okay, so that's a global variable, and as a rule, you don't get to use global variables in this class, okay? Because I said so. All right, that's the logic. So function prototypes. What is a function prototype? Well, you're basically declaring, you're telling the program there's going to be a function called stars, and so functions have a name, and then they have parentheses after them, and then they have some kind of a return type. Void is the return type of this function, and it means the function is not going to return anything. Okay, you can put variables in between the parentheses of the functions, and those are parameters, and we'll get to that in a second. So other than a function not returning a value, you can have a function return a value, and that is when you're going to put some kind of a return type, right? So int means returns an integer, float returns a float, char returns a character, you can have return a string, right? All these different ones. Okay? And calling the functions, right? So this is my function call inside of the main. As soon as I call the function, what's going to happen is I'm going to jump to my function definition. So the function prototype is on top of the main, right? My function call is in my main, and then my function definition, if I can find it ever, is after the main, maybe towards the bottom. There it is. So this is my function definition. As soon as I call my function in the main, I'm going to jump to my function definition. All right, function definition. All right, and I'm going to execute whatever's inside of my function body, or whatever's inside of the curly brackets of the function. So I go to my main. Where's my main? Right here. I call the function. I jump to the definition. I execute everything that's in it. I show the stars. And then if I wanted to call the function again, every time I call the function, it just executes whatever's inside of the function body. Okay? So that is a function that shows a value. Now, calling a function which returns a value. The return one function, right? What is that? Well, let me see if I can jump to the definition, right? Oh, that's neat. The function definition is here. What does this function do? It just returns the value 1. Okay? So here's my function call right here, right? So if I call the function right here, what happens is it will go to the function definition, it will bring back the 1 using the return, and there's going to be 1 in there. Okay? Are you going to be able to see this 1? No, because you don't have it inside of a cout, right? So if you wanted to see what value the function returns, call it from inside of a cout. If you want to store the value of the function that's being called, right? So this function, we're going to call it. We're going to go to the function definition. All right. We're going to get to the return. As soon as we get to the return, we exit the function at this point, and we return back to where it was called, and it brings back that value of 1, wherever it is. Right? Brings back the value of 1 here or here. Right? If it's here, you can see it inside of the cout. If it's here, it gets stored inside of the return value variable, and then I can use it later on, show it, or whatever I want. Okay? So this is how you call a function that returns a value. Either you make some variable equal to that function call, or you put the function call inside of a function. Those are some of the ways to call it. Okay, basically, if you want to see it, put it inside of a cout. Okay. The next thing that I did was, now I showed you the next step is a function which does not return a value, so it's a void called showNum, and it has one parameter. Okay, the parameter is the variable that we're putting inside of my parentheses for the function. Okay, so this parameter is num1, and we're going to accept some value stored in num1, and let's see the definition. So we're going to show that value of num1. Okay, so that's all there it is inside my showNum definition, showing that number. Okay, let's see how I call that function. showNum right here. Okay, so I'm calling it a couple of times, right? So I'm calling it this time here. I'm sending the value of 10 into the function. I'm passing the value of 10 into the function. As soon as I do that, right? Let me just copy this so you can see it. Right? This was my function. So as soon as I call the function showNum here, the value of num1 becomes equal to 10, and then I'm going to show you that here. Right? I'm going to show you that num1 is equal to 10. Every time I call the function, I'm passing a value into it. All right, so here I'm passing the value of 10. That is called the argument. Okay, so a function, the value that we're passing into the function is called an argument. You can pass different values. You can also pass a variable, right? So I can have a variable, a is equal to 100. Now a is my argument, and this value, this right here, is actually the exact same thing as this one right here. So whether I do line 114 or I do line 117, these two are exactly the same. Okay? What I'm doing is I'm passing the value of variable a. I'm not passing the variable a itself. Okay? So far so good? Alright. So the next thing is, what else did I have? Local variable, okay, pass by value. And this is something that I'm going to show you today in a little bit more detail. So first of all, so in here I have a variable b which is equal to 99. Then I show you the value of b here, and then I'm calling pass by value, and I'm sending b over into the pass by value function. What is the pass by value function? It's right here. This is my pass by value function, right? Let me jump to the definition. What's in here? Well, I'm saying b is equal to 0, and the next thing that I asked you last time is, so I'm passing b as my parameter, right? In here, I'm saying b is equal to 0. So what happens to the b that I have defined inside here, right? So I show you cout b is equal to, now at this point it should show 99, right? Then in here I'm saying, okay, pass b into the pass by value, and then in the pass by value I'm making b equal to 0, and then I have another cout b is equal to b. What was the value of b here? Zero? Both of you don't remember. Okay? So what happens is, when I change the value of b inside of my pass by value, where is this? Right here, right? So I'm changing the value of b here, right? This b, this variable b is actually a completely different animal than the variable b which I have inside my main. Okay, they're two different variables. Even though they have the same exact name, this b is different than the other one. Okay, so just because I went inside my pass by value, I send the b. Remember when I said I am actually just passing the value of b. I'm not sending b itself. Okay, so changing b inside of the pass by value does not change b inside my main, so it stays as 99. Okay. So that's one thing that I'm going to show you today. And that kind of brings me to the, again, to the topic of the different kinds of variables, right? This variable b is a local variable. What is a local variable? It's a variable which is declared inside of a function. This one is declared inside of the main function, which means that it's local only to the main. All right? That means that if I have some kind of a variable c here, for example, this is a variable c which is local to the main, which means that the scope of this variable is only the main. Scope refers to where the variable can be used, right? So what's the scope of C? I just said it. The main, right? The scope of a variable is wherever it was defined. A local variable is a variable which is defined inside of a main. So that means that the scope of C is just the main. Okay, let's go to function b in here. Well, so let's say, okay, so this is my function. This is my variable c here, right? If I wanted to, let me go to my pass by value. Where's my pass by value? Right? If I do pass by value and I try to do this business, why is this a problem? Because C is not defined inside pass by value, right? C belongs to the main. You cannot use a variable which is declared in the main outside of the main because it's local to the main. The scope of that variable is the main. Okay? So if I try to use it inside of any of these other functions, can't do it. Okay? And that is the difference between a local variable and a global variable. A global variable, again, going back all the way to the top, was one like this one. Right? So D, variable D, is defined, declared before any of the other functions. So before and outside of all the other functions means that it can be used inside of all the other functions. Okay, if I declared a variable inside of one of the functions, it can only be used and changed, for now, inside of that function. Okay, actually today I'll show you how you can break that rule. Okay, so and then again, the illustration that I did was if I run the program, all right, where is my memory address of main? So let's go back to my little Excel spreadsheet thingy. Okay, so what I do is, come on, you're not going to zoom in for me? Nope. Okay, so the example that I showed you was, okay, so I have in my main, so this is B in main, okay, and then I also have a B in pass by value, okay. This is variable name, right? So the variable names they're both B's, right? One is B in main, the other one is B in pass by value. Okay, the value that is stored, so value stored, is 99 inside my main, right? And this corresponds to memory address, and it changes every time I run the program. But this time I run the program, the value of B in main is, or the memory address, right? The memory address of my value B, which is inside the main, is this number, right? Some big hexadecimal number. There's many, many memory addresses, right? That corresponds to one of them. If I look at my B inside my pass by value, right? Memory address in my B inside my pass by value is actually something else. It's a different number. Okay? Since these are two different numbers, that means these are two different places in memory. So if I change the value of this place in memory, I'm not really changing this one. Even though both of the variables are called B, right? This one is B, the other one is also B. They're actually referred to different places in memory where different information is changed. So if I change this one to 88, that doesn't change this one. If I change this one to 100, that doesn't change this one, right? So again, there's variable B, which is defined inside my main, and pass by value, where are you? There's a variable B, which is defined as a parameter, and changing it for this function does not really change it inside my main. So that's why these two different variables have two different memory addresses. So what kind of a variable is B? Is it these parameter variables? Are they local or global?
You said B is or B?
B.
B is local.
It's local.
Yeah.
That's what you're saying? Okay, yes. So B is a local variable. I have defined it to be used only for this function. So it's local, right? So what's the scope of B then? It's the function passed by value. So the scope of B is the function where it was defined, right? So when I say scope, I mean where can it be used? It can be used inside of the function where it was defined. It was defined in this function. So that's the scope of the B. Okay? And again, both of these are two different variables, right? So let's try this again. What's the scope of this variable B? It's defined inside of my main, by the way. It's my main. All right, good. Nice. All right, good. So spoiler alert, B, the scope of B in the main is the main. Okay? So now you understand that when you are passing a variable into a function, you're not really passing the variable itself so that it could be changed, at least not yet. I'll show you how you can do that today. Okay? And now you got the hang of what's a local variable and the scope of things, right? The next thing that I showed you was functions calling other functions. So I have a function B, right? I'm going to have a couple of functions defined here. I have function B and function A, right? I want to have these functions, I want to have their prototypes before my main, okay? So that the order in which I call things doesn't really matter. Right? In this case, I have function B and then function A after it. If I did not have my prototypes on top, so let's say I go in there and I take these out. Done. Alright? Now when I go to my function definition, look what happens with function B. We go to function B, right? We call function B from the main, then we jump to the function B definition. We go top to bottom, line by line, just like every time the program works. We get to the call of function A and then it goes, wait, what? Undeclared function A. It is declared, but it's declared after. So since the program works top to bottom, when it gets to this point, it can't see yet that there's a function underneath it, which is why you're going to get an error. Which is why I'm saying to use prototypes for every one of these, right? We're going to have prototypes on top. That way, it doesn't matter in what order you call these functions. You can have function B, and then in it you call function A. Function A is defined after that. No big deal. The program knows about where function A is from the prototype. Any questions? Okay, so in this particular case, you have function B is being called by the main. Where is this thing? Let me see. So for function B, we call function B in the main. Right? Then we go to the function B definition. We execute whatever's in it. We get to the function A call, and then we jump from there to another function. So you had the main function called function B, which in turn calls function A. So you can have different functions calling each other. Make sense? Huh? Any questions? Okay. So now we know how functions call each other. Then the next thing that I showed you was, well, look, you could have a function. Let's say I'm going to make a function called sum. All right, let's go look at the sum first real quick. Sum is this. All right, so what can we say about this function? Well, the name of it is sum. It's going to return a double, and it has two parameters, n1 and n2, which are decimal numbers. They're doubles, right? So that means that when I'm passing values into this function called sum, I hopefully am passing double values, right? So make sure that when if your parameter is a double, make sure that your arguments are doubles, right? So these are, in this particular case, I actually used integers. It is okay for you to use integers when you're supposed to use doubles, but it's not okay to be using doubles when you're supposed to be using integers. Because if you have some kind of a decimal number like 3.14 and you force it to become an integer, what's going to happen?
Would it give you like an error message?
I mean, sometimes it could give you an error message depending on what language you're working with. What's going to happen in C++ most likely is if you try to do this, let's say I have int a is equal to 3.14 or whatever, 14, right? I'm redeclaring it. Let's go x. Okay, and then if I do, what don't you like? Okay, fine. Then I'm going to do cout x equals x and L. Okay, what is it going to show me here?
Or just the 3?
Just the 3. Yeah. Okay. So yeah, if you're forcing a double inside to fit inside of an integer, you're going to end up truncating the decimals. You're not going to have any decimals. Okay, so be careful. But if you have a double, double here, and you're making that thing equal to 3, no big deal. It's still a 3, right? Maybe 3.00, but it's still a 3. You didn't lose anything. Okay, so that's what happens here. I am asking the user to enter 2 values, a and b. Then I'm going to pass these 2 values into the sum function. I could also pass just numbers or variables, doesn't matter. And then my sum, where was my sum? Here it is, right? So these are my 2 parameters, n1 and n2, which were equal to whatever values I passed into the function from the main. Let's say we had a 30 and a 40. This is your 30, this is your 40. Total is equal to 30 plus 40. Then you return total, and you're out of that function. Okay? So that was basically this one right here. So if I have like 30 and then 40, then I have a bunch of function calls in there. Okay? 30 plus 40, a bunch of times. So the reason why that is because I don't know. Oh yeah, there you go. This is my first time calling it, this is my second time calling it, and this is my third time calling it. So 3 different ways that I call function sum, and it gives you the same results every time. Okay? Any questions? Sure? Positive? Still awake? Okay. So that is, and then I had a few hints in there from, for the assignments from last week. I'll just skip those. So what I'm going to do is I am going to leave everything. I'm going to delete everything except this one here. Okay, that we're going back to the memory to the passing by value, pass by value is the only one I want to leave. Erase this and everything else. Where's my pass by value? There you are. Let me erase all these other ones so that it's not too much stuff in there. And I'm going to erase this stuff here too. Okay. So let's go back to this little thing here. All right. So I only have 2 functions. All right. Well, I only have 1 function, right? And then again, the whole thing with the b, how we have a b in the main, right, which has its own memory address. The way you show the memory address of a variable is with the ampersand sign. All right. So if I run this thing here, let's do it again. All right, this is my memory address of B, right, in the main. And then this thing changes every time I run the program. So now it's a different number, right? And the value of that thing is 99. And then if I go in my pass by value in here, I have a variable B, which is inside my pass by value. I can show the memory address of B with the ampersand B, and that is going to be a different memory address, which is some other number. And then when I make the variable b is equal to 0 here, I'm changing this value in here, which corresponds to this memory address. Okay, so changing this does not change this. That's what I showed you, a couple of minutes ago. So now what I'm going to do is I'm going to show you how you can go around that. Okay? So, and in order for me to do this, I'm going to introduce pointers. Okay? Let me go back real quick. So this is now, we're on week 7. Prime numbers. Yeah, I'll tell you a little bit about pointers because it has to do with this chapter here. Okay, so now, let's say I am going to have a couple of variables. So I'm going to have an int a, little a, which is equal to like 101. Okay? And then what I'm going to do is I'm going to show you cout value of a is a and L. And then I'm going to do a cout and I'm going to show you the memory address of a. This is memory address. Memory address of a is equal to %a. Okay? Alright, so if I run the program, this is my memory address of A. Alright, we get to see the 101 here. And then I get to see the memory address here. Okay? So far, so good. Nothing new. Now what I'm going to do is I am going to show you pointer. Okay, so here now is a pointer variable. Pointer variable. Okay, and what is a pointer variable? Pointer variable is a variable that stores the memory address that is equal to the memory address of another variable. Okay? And how do you declare a pointer variable? Well, int asterisk a. Okay, so now asterisk a is the pointer variable. Asterisk a is declared as a pointer variable. Yes? Okay. Just like so, let's keep track of things. So we're gonna have, like, say you have a. So this is a in main, right? And then you have asterisk a in main, right? So the memory address of a in my main is some number that's going to change again, but whatever. So come on, there it is, right? So that's my memory address of variable a in the main, and the value stored in my a in the main is what? What is a equal to? 101. Beautiful. You're a genius. Okay? 101. Okay? So the value stored in the main, all right, is 101, and the memory address of the a in the main is this thing. Okay? For now, every time I run the program, it will change the memory address. Okay? Similarly, let me try to show the value of the pointer a in the main and the memory address. Okay, so first thing I'm going to do is I'm going to do a cout memory address of asterisk a equals, and I'm going to do %a and L. Okay, run it. Okay, so memory address of little a might have changed a little bit. It did. Changes every time. Right? It changed to this. And then my variable memory address of a asterisk is this. Okay? 2 different memory addresses. Now let's look at what is the value that is being stored inside here for the a. Okay? Let's have a look at that one. So I'm going to go in there. I'm going to do a cout value stored in the memory address for asterisk a is, and L, and maybe I should have shown that a. There you go. Okay, so what do you think? What kind of value is going to be stored in here? If this is a pointer variable, And I already wrote up a bunch of stuff in there in green. Let's have a look. So I'm going to run this thing. It's some weird number like this. All right, let me run it again. Maybe we'll change something else. No. Is this. All right, so this is the value that is in there. Okay, well, this value right here is actually some kind of a memory address. Okay, so the value that is stored in a regular variable is just a number. The value that is stored inside of a pointer variable is the memory address, some memory address. Okay, it's not like a, we haven't changed it to equals to some other variable just yet. Okay, what I'm going to do now is I'm going to tell it, okay, this memory address here, this one, if I can select the damn thing, all right, that is going to be equal to the memory address of the little a. Okay, so how do I do this? So I go and I say, okay, make pointer a equal to the memory address of little a. Okay, and it goes like this: a equals ampersand a. Okay, as soon as I do this, now this variable a, the value that is being stored in variable a, is going to be exactly equal to this value right here. Right? This value is going to go in there. And let's run this thing again, because these are going to change again when I run the program. So memory address of a is this. Right? Then memory address of asterisk a is this. They change. Then, oh, I forgot to show it. Damn it. I'm going to have to do another cout right here. Run it again. Alright, so memory address of a is this. Memory address of pointer a is this. Okay? The value stored in memory address of asterisk a actually changed now that I ran it to this. Alright? There's just some random garbage number stored in there. Right? Just like you'd have garbage numbers stored in little a. If I don't initialize it, it will be equal to some random number. That is similar to how this thing is equal to some random memory address. This is not equal to this. This is not equal to this. It's just some, remaining number that is left in memory just floating around that were equal to that. Okay? Now what I'm going to do is I'm going to update this address to become equal to this one. That is with this line right here. And then that is value stored in memory address of asterisk a is equal to this. I'm going to copy this, paste it in there, and you're going to see that this is equal to that. Okay? So now at this point, pointer a points to the very little variable a. Okay? Okay? So let me just copy this. So memory address of little a is this. Memory address of big A, alright, is this. Actually, no, that goes here. Okay? The value stored in memory address of A initially was this, right? Some garbage number. And then the next thing that I'm going to do is I'm going to change this thing equal to the memory address of little a, and now I'm updating this address to become equal to this. In other words, this value changed to this, which is equal to this. Right? So now a, at this point, pointer a points to little a. Okay? And what's the purpose of this? Well, you can change little a through big A. Okay, so what I'm going to do is change the value of little a using the pointer big A. And it goes like this. I'm just going to say, okay, so this one was 101. I'm going to say, okay, well, asterisk a is equal to 89. Okay? Then, if I wanted to show you the value of little a, which used to be 101, right? You're going to see 89. Okay? If I run it, little a is 89, right? So by saying asterisk a, right? Now that I made pointer a equal to the memory address of the little a, when I say asterisk a, I'm actually changing this here to 89. Any questions? Positive?
Yeah.
Okay. So this is 89. So these are pointer variables. Okay. And pointer variables have a whole lot of uses. So when you get to data structures, which is your, in the future, I can see your future. You're going to have to do a whole bunch of pointers, right? You're going to have to do pointers for arrays. You're going to have to do pointers for linked lists and a whole bunch of other things. So you better understand how pointers work and what they are. Okay, we're sure we got this? Okay, so again, all it is, it's a special kind of a variable which is equal to the memory address of some other variable. Okay, and you can actually have pointer to a pointer. Those are called double pointers. There's actually triple pointers, and the madness continues, right? So you can have many, pointer to a pointer to a pointer to a pointer. Okay, we're not going to go there. So now that we understand pointers, what I'm going to do is I'm going to create another function. I'm going to call it void pass by pointer. Okay, pass by pointer is going to have an int asterisk b. Okay, so just like the one on top, except we're putting a little asterisk in there. So I'm going to grab this thing. I'm going to go after my main, right? And I'm going to throw that in there. And then in it, just like I did with this stuff here, b is equal to 0, I'm going to say asterisk b is equal to 0. Okay? Then when I call my my function in my main, right, I'm going to go in there, and where do I want to do it? Let me do it right here. So I'm going to say, all right, cout. Not that you don't, well, you already see it. So cout, you already have a b is equal to 99 here, right? So what I'm going to do is I'm going to call my pass by pointer, but instead of sending the value of b, I'm not passing the value. What I'm going to do is I'm going to pass the memory address. Okay? So pass the memory address of b into pass by pointer. Okay? So what happens? I'm sending the memory address, and just like I did this right here, this pointer variable a is equal to the memory address of little a. That's exactly what happens here. When I say %b and I have an asterisk b, this asterisk b is going to become equal to this variable, or actually, yeah, this pointer b is going to become equal to this memory address here, just like I did with this here. Okay? So now b refers to the same thing as the b in the main. In fact, let me just call this something else. I'm going to call this z, just so you know it's something different, right? Z, right? And I'm going to change this thing to z also. This is a z, right? So changing z here, what is going to happen when I do this here? What is going to be the effect of b in my main? What is b going to be equal to when I do this here? It was 99 initially. When I did a pass by value, it was 99. I call pass by value, right? Pass by value makes b equal to 0, but then we come back, and you can see that that did not change the value of b in the main. But now I'm doing pass by pointer. It should be 0, right? I do a pass by pointer. I'm sending the memory address of b. We're going to the pass by pointer. I'm saying z, which is not even the same name, right? But it points to that variable, is equal to 0, just like I did here. I basically, with my function call right here, in line 24, I'm actually doing what I did right here with this pointer. And then whatever I'm doing inside of my function right here in line 64 is the same thing that I did right here. Right? So what happened here was using asterisk A, I was able to change the value of little a. And here, when I use asterisk Z, I'm going to change the value of B. Right? So this thing here, hopefully, it will show as a 0. Okay? I run it. And B is 0 right here. Okay? Any questions? Yes?
Could you reverse it, like instead of doing asterisk A, big A is equal to little a? Could you do it like the opposite, like little a changes the value?
So you're saying, can I change the value of A using
Little a.
little a? No.
No? It's only
No.
pointer.
No. Yeah. You cannot change the value of the pointer through the variable it points to. You can, if you change, yeah, in a way, changing one changes the other, basically. Okay, so let's do this. Here, asterisk A is equal to 89, right? So that changes the value of little a. So I guess the answer is yes, you could. So check this out. So in here, I'm going to say little a is equal to 1, 2, 3, 4, right? Then if I do cout asterisk A equals asterisk A, what do you think this is going to be equal to now? 1, 2, 3, 4. Right? So yeah, changing one changes the other. But not the memory address, it still points to that. They're connected. Those two variables are connected. Changing one changes the other. But I cannot, I can change only the value that is stored in the memory. With whether I use one or the other, same thing. Okay? Good question. Any other questions? For those of you that are awake. Yeah, I'm looking at you.
I took a little bit.
Yeah, all right. Take a nap before class next time. All right. So this is a pass by value, pass by pointer. Pointer is very important. Like, this is your practical application. Well, what would you use something like this for? Well, maybe an input, right? Let's say I have some kind of an input. So I'm going to say, okay, void input. And I'm going to have an int asterisk little a, int asterisk little b, int, well, let's do x, y, z. So x, y, asterisk little z. All right. So that's my input function. What don't you like? Public. Okay, never used. I go and do this here. All right, and then in here I'm going to do something like cout enter. What do I want to use here? ijk. Let's go with ijk. So I'm going to do int ijk, right? And then I'm going to do input, and I'm going to send the memory address of I, the memory address of j, the memory address of k, right? Then in here I'm going to say, okay, well, enter value for I, cn asterisk x, and I'm going to do the same thing for the other two. All right, this is j, and j is the asterisk y, and let's do the k, and that is asterisk z. Okay, and I can make these things to whatever I want. Let's go give this thing equal to -1, equal to -1, equal to -1, and then I can show you these values. Cout I equals I, j equals j, and k equals k, and l. And what are these going to be equal to?
-1?
Nah.
Oh, no, there would be to the memory of it?
Well, whatever the user enters. The user is going to enter some values here, As soon as they enter a value, we're going to do asterisk x. When you do asterisk x, you're actually changing the value of I. When you do asterisk y, you're actually changing the value of j, because I sent the memory address of j for the pointer y. Okay? And similarly, when I do asterisk z, I'm going to be changing whatever this value is, because I sent the memory address of k for the pointer z. Yes? So, if I run this thing, it's going to ask me to enter a value for I, 100, 200, 300, and voila. Alright? These changed. Okay? So that's one practical application for why you might want to have, pass by a pointer in a function. Right? Make sense? Any questions? All right. So the next thing that we're going to do is, I guess I'm just going to go through these, give you some hints, and see how far we get. Okay. So now we know this next one. Okay, so the number 6 is a truly great number given to integer values a and b. Write a function that returns string great if either value is 6. The function returns great if the sum or the difference of the value is 6. The function returns not great otherwise. Okay, and what I do is I give you the function prototype, and I give you the definition. I give you how it's supposed to be called in the main, and then how it's supposed to work. What you have to do is you have to write the definition. Okay? So I'm going to grab my prototype, copy that thing, and I'm going to throw it right here on top. These are your hints. That's that. And this is 39. P39. Okay? Then I'm going to go after my main. And again, this is your hints. Hints. Alright, that's there. So then this one here is, how does it go? So, two integer values a and b, write a function that returns the string great if either value is 6. So, if my a is equal to 6, or my b is equal to 6, right? What else do I have? The function also returns great if the sum or the difference of the values is 6. Okay, I also have or if my a plus b is equal to 6. Right? Or if my a minus b is equal to 6. Or if my b minus a is equal to 6. Right? So those are the possible different ways that this thing could return true. Or no, returns great. And that's it. Otherwise, then I'm just going to say return not great. Okay? Any questions on this? Alright, so what I'm going to do is I'm going to erase part of it. You do the rest of these. Alright, you do the difference. Okay? Alright, so what if I had a...
Question.
Yes?
So on the first return, I thought it's just cancel it on the first return. How come you're giving a second one?
Because the logic is, I have a first return. If I get to this one, I exit at that point. And if I never got to this one, then I'm going to go to the next one. So I only go to this return if I happen to, if I can go inside of my if, right?
Yeah.
And what if I had cout high here? When is that going to show? It wouldn't. Why?
Because either the first one's true or the second one's true.
And then so yeah, this will never show because either this is going to happen or this is going to happen. And what happens when you get to the return?
It stops.
Stops. You get out of the function. Okay, so this here will never show. So just FYI, right?
But you don't have to write else for a return.
I could do else. So if I do this, it will work exactly the same. Does that make sense? So if this is true, then I'm going to go to this return. But if it isn't, I mean, I could use an else and then it was going to go to the return, but I could just do this and then it will get there anyway, right? Without else. Okay, so that's the 39. And going to 40. And the 40 is given two integer values, return true if one is negative and one is positive, except if the parameter negative is true, then return true only if both are negative. Okay, I don't give you anything other than just the function prototype and what it's supposed to do. So I grab this thing, alright, throw it in there. Alright, this is your P40. And I'm going to put the definition here. So this is P39. This is 40. Yeah? Okay, so how does it go again? You have two values. Your two values are val1, val2. And you're going to return true if one is negative and one is positive. Except if the parameter negative is true, then return true only if both are negative. So there's this parameter. So let's start with that one. So if my negative is true, right, then return only if both are negative. And val1 is less than 0 and val2 is less than 0, then I'm going to return true. Whoops, lowercase true. Okay? And this thing kind of highlights the thing for me, or C-line highlights the code for me, because I can actually make this thing simplified. So I'm going to take this out, copy it, paste it, and I'm going to, instead of equals true, I'm just going to say if negative. Because negative is either true or false, I don't need to say equals true. Okay, so this thing is the same as the above. Same as above. Okay, it's just a little shorter. You don't have to say equals true. If it is a Boolean variable, it's either equal to true or not. So you don't have to say equals. Okay, so if this parameter is negative and both of the numbers are less than 0, then you return true. What else do we have? Otherwise, return true if one is negative and one is positive. Okay, so if one of them, so I'm going to do, that's my first, then I'm going to say else if, actually I don't even need to, I'll do an if. Alright, so if my val1 is less than 0 and my val2 is greater than 0, one negative, one positive, right? I'm going to return true. And there's another one, which is if my val1 is positive and my val2 is negative, that will also be returned true, right? And then you have one more, which is the return false. So if it is not going to be true for any of these, I'm just going to do just like I did before, return false. All right? I could have done if, what don't you like? Statement can be simplified. Really? I don't care. Else if, I could have done this, and I could have done else, and then do this. Right? That would pretty much work the same way, except some compilers are very picky, and some of them, like say C-line or whatever, they might go in there and tell you, well, what if none of these are true? What is this thing supposed to return? Even though it doesn't really make sense, one of them will always be true. Some of the compilers are so picky that you have to basically rewrite it to be like this, pretty much. Okay, so this is the default return. Okay? Got it? I pretty much solved the whole thing for you. So I'm going to do, let me take out one of them at least. All right, do one more if. All right. Okay. So that is your 40. Let's look at 41. Lonesome. back. Okay, so given 3 integer values, return their sum.
Thank you.
However, if one of the values is the same as another one of the values, it does not count towards the sum. Okay, so in this particular case, we have a couple of different codes. All of these 3 are different values, so you're going to return the sum of all 3. In here, you have the first one is the same as the last one, so they're not going to count. You're going to return this one. Okay, and in the case when they're all equal, then you just return a 0. Yes? All right. So let's go in there. This is your 41. All right. And let me copy the prototype. All right. This is your P41. All right. I'm going to go do my definition. P41. Okay. So how did it go? If 2 of these are the same, they don't count. So if, and by the way I would recommend you write these is, imagine what are the possible ways this could work. Right? So let's say I'm going to go do this here. Ooh. That's pretty cool. Let me do this. So these are the possible ways that this could work, right? So you can have a 1, 2, 3 and then it returns a 6. You can have a 3, 2, 3 and then it returns a 2. You could have it in different ways too. You could have it 3, 3, 2, 3, 3, 2, right? Then these 2 are the same and then returns a 2. You can have it also as 2 is first. And then these 2 are the same, right? So I'm trying to arrange these in every possible way that I can, right? All of them are different. 2 of them are different. First and last are different. First and second are different. Second and third are different. And they're all the same, right? And then using these possible test cases, that is where I'm going to write my ifs. So what's my if for the first one? So if A is not equal to B and B is not equal to C, right? This one's not equal to this one and this one is not equal to this one. They're all different. Then I'm going to return A plus B plus C, right? Then go to the next one. Okay, now the second and third are the same. Right? And if you want to, you can also do this. You can say, okay, well, this is my A, this is my B, this is my C, right? So now we're doing this one, right? So the A and the C are different, are the same. So I can say, okay, if my A is equal to C and my B is not equal to either the C or the A, since they're the same, it doesn't really matter, right? So A and C are the same, B is not equal to C. What do I return in this case?
B.
Awesome. Return B. Okay? And similar to this, so we did this, done. We did this, done. Right? Do the rest. Okay? And what is going to be the default return? This will be the default return. So just like we did with before, I just do return. What will be the default return?
Return 0.
Awesome. Okay. So I'll do the other ones here. Do the other 2 ifs here. Okay. So that is your P41. Let's go to the next one. P42. Randint. Okay. Now this is something that's very useful because you're going to have to make random numbers a whole lot in this class. So after you create this function, that will simplify your life and you're welcome to use your code, right? For any assignment, you're welcome to go back and use any of the other assignments that you've done before. So as soon as you're done with this, now you can have a function that will make random numbers for you. Easy. You don't have to think about, all right, what I have to add, you have to do time no and all that crap. No, just use the randint. Okay, so first of all, I guess I'm going to show you a whole lot. So first, this is, I'm going to be calling my random number here. So let's say int random num is equal to, let's say, randint between 10 to 20. Right, that's how it's going to work, and I'm going to show you cout random num is equal to random num and L, right? And I can say this is a value between 10 to 20. Okay, so let's write the randint. So randint, this is 42, int randint, it's going to take a min, it's going to take a max, right? Int, and this is 42, p42, right? I'm going to grab this thing, I'm going to take it down to my definitions. So this is now hints for 42, p42. Okay. How do we make random number? Well, first what we're going to do is we have to do this business here. We have to do int I seed. I can do it. Let's do it here. Int I seed is equal to time null. That was the first piece. Then I do srand is equal to I seed. Right? So these have to be here. So put these two. Put the above two lines in here, not in randint. Okay, if you do it, if you put these two lines in randint, it's not going to make the same. It's going to make the same number every time, and I can explain to you why that happens if you want. Okay, so we're putting these two lines here, not in randint, and then inside my randint, I'm just going to say, well, return min plus rand modulus max. How did it go? Remember? Okay, max minus min plus 1. That's how you make a random number. Okay, so then the idea was basically, if I want to make a random number if I wanted to make a random number from 0 to 5, right? 0 to 5 random number, I do rand modulus 6, right? So this right here makes me a random number from 0 to 5. Okay, if I wanted to make a random number between 10 to 15, then what I do is I say, okay, well, I'm going to have a 10 plus rand modulus 6. So what happens is I have a 10, and then I'm adding a random number between 0 to 5 to it, which was that early one. So then you end up with a random number which is between 10 to 15. Yes? Well, this number 6 here is, if you look at the 6 is equal to 15 minus 10 plus 1, which is the max minus min plus 1. Okay? And then this is your min here. All right? And that's the idea. Okay? So there you go. That's your randint. I pretty much solved it, so don't look at it. Try to solve it without looking at it. But if you get stuck, that's what you have to do. If you put these two lines in here, right? If you move these two lines in here, what's going to happen is when you run the program, it's going to get the time, the system time. And the system time is going to stay the same no matter how many times you call the function, right? Which means you're basically going to give it the same big number here every time. But what's going to happen is this. So if I have, let's say, suppose I do this. So I'm explaining why it's not going to work if I put these in there. So if I have this here, and let's say I have a 0, right? If I do this with 0, this is always going to generate some kind of a list of, pseudo-random numbers like that, right? And that list goes on forever. Very long list, okay? But for the value of 0, every time I call rand, if I do a rand modulus 6 here, right? What that is going to do is it's going to grab this number, right? It's going to do basically 456,253 modulus 6, which is going to reduce it basically to some kind of a random number between between 0 to 5, right? Because that's how this works. You can get whatever huge magic number you want, and you do modulus 6 to that thing, and you're going to end up with a random number between 0 to 5. Okay? If I do this again, all right, I grab this thing, and I do it right here. Then it's going to grab the second number from this list, and then again, it's going to make some random number between 0 to 5 based on this number. If I do it another time, all right, why did I type the same number twice? Yeah, can't even, there you go. Okay, if I do it another time, then it's going to grab the third number in that list, and again, it's going to use that to make a random number between 0 to 5. Okay, but if I did this, that is one thing, right? Now if I did this on the bottom, so I'm going to do this. I'm going to say srand 0, and then I'm going to call this. Alright? Alright? It will pull that first random number. If I do srand again, and then after that I do srand again, I do rand again, what it will do is it will grab the first number again. So every time I do a srand with the same number, the rand thing is going to pull from that list of numbers, right? And we're going to make it restart at the first number every time because I called this, right? And that's what's going to happen. So if I do it one more time, right? If I do it one more time, it's going to grab the first number only. So what's going to happen is if I ran this thing 3 times, you're going to end up seeing the same random number 3 times. So this is why you don't want to put this, and by the way, I just used the 0 here, but if you use iseed is the system time when you ran the program. And if this happens to be inside of your function, what's going to happen is you're basically going to be resetting it to the same system time you call the function, which in turn is going to make it grab that first number from the list of numbers every time, so you're not going to get the random numbers. Got it? I hope. Okay, so I'm going to take these out. Alright, and that's how you make a random number using randint. You're going to have to use this all the way up to the final project. For the final project, you're going to make a random number and use your randint function. So use it, create it, make sure you understand how it works, and then use it. So the next one is 43. Alright, let's look at the 43. Write a function sleep in with 2 parameters, weekday and vacation. The parameter weekday is true if it is a weekday, and the parameter vacation is true if we're on vacation. We sleep in if it's not a weekday or we're on vacation. Return true if we can sleep in. So this is your number 43. Alright, so let me grab the prototype. This is 43. Okay. And I'm going to throw the definition here. Okay, and how does it go? You can sleep in if you're on vacation. It's true for a vacation. We can sleep in if it's not a weekday or we are on vacation. So we have 2 Boolean parameters. So if is not a weekday and if it's not a weekday or we are on vacation, then you return true. Okay? That's basically it.
Would we have to put it so that they have to input if it's like what what day is it, or like are you on vacation?
No, when you calling, so when you call it, so how do you ask the user to input things? You don't have to do that at all. You just do cout sleep in, and let's do like a true false returns, and then you do sleep in true false. You can just do that to test it. Okay, so basically what I'm telling it here is it's a weekday and it is not a vacation. So if it is a weekday and it is not a vacation, then this is not true. So what I will do is I'll just return a false. That's pretty much it. Okay, so this is one way to do this. Another way to do this is I'm going to write it on top. You can say if weekday is not equal to true, or vacation is equal to true. So this here, all right, same as the above. Yes? So that is your number, whatever this is, 43. P43. Okay, going to the next one, 4-4. I got 2 more left in 5 minutes. We have 2 monkeys, A and B, and the parameters A smile and B smile indicates if each is smiling. Okay, we're in trouble if they're both smiling or neither of them is smiling. And here's your prototype. All right. So go through them. Go to the top. Do P44. All right, that's my prototype. Whoops, too far. And this is my P44. Get rid of the semicolon. And we said that we're in trouble if they're both smiling or neither of them is smiling. So if A smile is equal to true and B smile is equal to true, right? That's when you're in trouble. So if that's the case, you return true. All right? You have to write another if, and then write the default. The default return. Okay, so a couple of things. This one here, I can actually simplify this by just saying if A smile, right, that will be the true one, and not B smile. All right, so this here, same as the above. Yes? All right, so that's your 44. Next one, 45. And I'm not going to do the 46 and 47 because those are extra credits. I will do them next time. Okay? Next time we're going to be reviewing for the midterm, which is, I don't know when. We'll find out in a second. Okay, so given 2 integer values, no worries. Given 2 integer values, return their sum. Unless the 2 values are the same, then return double their sum. Okay? So, this is your prototype. Grab this thing. Alright, this is my 45. P45. And here's your 45. P45. Alright, so how does it go? Given 2 integer values, return their sum unless the 2 values are the same, then return double their sum, right? Okay, great. So that is basically if value 1 is not equal to value 2, then you return value 1 plus 2. Okay? And then what you got to do is write a default return. Write a default return. So if they're not equal, then they must be equal, in which case you're going to return value 1 plus value 2, the whole thing times 2, right? 2 times the whole thing. That is the other one. Okay? Any questions? All right, so that's it. All the hints, and more than I probably should give you. I pretty much solved most of these for you. And as you can see, it doesn't take a whole lot of time if you know what you're doing. Not to say that I know what I'm doing, but yeah. So this is 3, 6, 7 assignments with functions. You should be very comfortable with functions. You should know how to return, how to show, how to pass values into the function, know what a parameter is, because you're gonna a bulk of the midterm is going to be with functions. Okay, if you don't understand the basic term, if you understand the basic terminology of functions and how to use them, midterm will be a piece of cake. And if you don't, you're not going to do well. Okay, so make sure you get functions, get plenty of practice with them. If you need to rely on my hints, once you've done it, go back and do it again without looking at the hints, without looking at your work. Okay, so that is it. If you have any questions, send them to me. Come see me in the office, and I will post the video.
For the midterm,
Yep.
is it going to be like questions of like how do you make this work, or is it us going to be writing?
You're going to be writing a program. Yeah, so for the midterm, which is actually next week, midterm is next week. Next week it's take home, so don't worry. If you have any questions on the midterm, you're welcome to check with me in advance before you turn it in. You want to say, hey, look, does this work? Is this what you want? Fine, I'll look at it, and then you can turn it in and you get full points. If you don't want to do that and you turn in the midterm and you don't do well, I offer a regrade, just like with every assignment, except on the midterm, I give back half the points that you lost. So if you got 50 on the midterm, which you would only do if you don't check with me in advance, right? But if you get a 50 on the midterm and then you want to resubmit it, you can get half of your lost points back, so you're going to go from 50 to 75 at most. Okay? So check with me in advance if you want. No big deal. And yeah, and the midterm is already posted. You can look at it. There they are. There's going to be a multiple choice. You're going to have to debug a program without a compiler and then write a couple of programs. Okay? So that's all. Let's get out of here because these people are rushing.